Okay. Number 4, find the heat required to bring 15 grams of Z from -40 to 105. When I have a problem with the temperature change like this, remember I need to check where it is, whether it's a solid, liquid, or gas at each point, and know if it changes phases. So we're given the melting point and the boiling point. So between -30 and 90, it's a liquid. Below -30, like -40, it'll be a solid. And at 105, which is above 90, it'll be a gas. Knowing that I have a phase change, I'm going to make a heating curve. The temperatures that I put on it: starting point, ending point. And then I want to put in the melting point and boiling point, not of water, but of Z. -30 and 90. My heating curve increase from -40 to 30, level off, increase to 90, level off, increase to 105. So this is going to have 5 distinct phases. So I'm going to need to calculate 5 separate Qs. For the first one, I have it changing temperature. Since I have a change in temperature, I'm going to do mass times specific heat times change in temperature. The mass of Z is 15. At this phase, it's a solid. So since it's a solid, I want to use the specific heat of the solid, which is 0.85. And then my temperature change from -40 to -30 is 10 degrees. Multiplying these through, 15 times 0.85 times 10, 127.5 joules. Step 2, I'm at the melting point. So I'm going to do Q equals mass times the heat of fusion. The mass of Z is still 15. And then I need to pick the heat of fusion of Z. So multiplying 15 by 125, 1875 joules. My third phase is this temperature change. So since I'm changing temperature, it's going to be mass times specific heat times change in temperature. The mass is 15. The specific heat, I'm now in a liquid phase. Specific heat I use in the liquid phase is 3.25. And they're cut off here, but remember we've got these column headers up there that tell me which value is which. Temperature change from -30 to 90 is a total of 120 degrees. 15 times 3.25 times 120, 5850 joules. 2 more steps to go. Okay, my fourth step, I'm at the boiling point. So at the boiling point, I do Q equals mass times heat of vaporization. The mass is 15. The heat of vaporization is 1980. (29,700 joules). All right, my last step before I add them all together is this slanted region where we're changing temperature. Anytime we're on a slope, we're changing temperature, which means we're doing Q equals mass times heat of, times specific heat times change in temperature. Mass is still 15. The specific heat, I'm now in a gaseous phase. So I'm going to use this value of 2.88. My temperature change for this phase is from 90 to 105, which is a temperature change of 15 degrees. 15 times 2.88 times 15 gives me 648 joules. Now, what I need to do to get my final answer, I need to add this number, this number, this number, this number, and this number together. All 5 of the joules need to be added up. 127.5 plus 1875 plus 5850 plus 29,700 plus 648. Giving me a grand total of 38,200.5 joules. In my experience, the most common mistakes by people who are really close to getting it right is just simply in the data entry when you're doing the adding. A lot of times somebody forgets a 0. I recommend checking that step twice of the summing. You also could have put your answer as 38.2 or so kilojoules if you preferred. That would have been just fine.